Welcome back to Advanced Functions, another rational functions unit. In this lesson number 3, we are going to look at the graphs of a rational function of the form that is in y is equal to ax plus b over cx plus d. Okay, so there are two different scenarios that I'm going to take a look at. Now, so this is case number 1. So case number 1 is that c of x plus d is not a factor of the numerator. So that means it doesn't cancel out. So to find the domain is you always look at the denominator. So you let cx plus d cannot equal to 0. So x is equal to cannot equal to d over c. So we say that x cannot equal to d over c. Another way to write it, so you can say the range dash this negative d over c. It means that the domain x can be any real number, but it cannot be equal to negative d over c. Okay. Range, same thing. As you can see, range, it can be any real number, but such that the degree, assuming that it's the same degree of 1, that means we have a horizontal asymptote at the same coefficient, a over c. So it cannot be equal to a over c because that is my horizontal asymptote. Again, same thing, we have a vertical asymptote as well. So to find the x-intercept, you let y is equal to 0. Okay, so in this case, it's going to be the numerator. So numerator ax plus b equals 0, and then you get x is equal to negative b over a. And to find the y-intercept, you let x equal 0. Okay. And then for symmetry, it can be odd or even. So you would have to do the symmetry test. So for even, it's going to be negative x is equal to my original function. And if it's odd, negative f at negative x is equal to f at x. So that's even, and that's odd. Okay, so that's the only way to figure it out in this case algebraically. And for continuity, everything is continuous except there is a break at x is equal to negative d over c, which is a vertical asymptote. So let's do this practice. So find the characteristics of f at x, then graph the function. So I'm going to graph this. So f at x, so it looks like I could factor the numerator by 2. So 2, x minus 2, x plus 2. Okay, so unfortunately nothing cancels out, so that means there's no hole. Okay, no hole. And for the domain, it looks like x cannot be equal to negative 2. So to find the zeros, you're going to let the numerator equal to 0. So 0 equals 2, x minus 2. So it looks like x cannot be, so x is 2, right? And then vertical asymptote, you let the denominator equal to 0. So x plus 2 equals 0, the denominator. So x is equal to negative 2. So that's my vertical asymptote. My horizontal asymptote, so as you can see, the degree is the same. So it has a degree of 1 and 1. So if it's same, you look at the coefficient of the degree. So it's going to be 2 over 1. So y is equal to 2. Let's find the y-intercept. So y-intercept, to find it, they're going to let x equal 0. So let's plug in x equals 0. And when you do it, 0 minus 2, you're going to get negative 2. Okay, so let's graph with all the information. So we have x, y. So I'm going to I'll write down some key points. So this is 2. I need to know this. And I have a vertical asymptote at -2. I have y-intercept at -2 and 2. Okay, so using a different color, so I have vertical asymptote at -2, and I have a horizontal asymptote, at y is equal to 2. I have y-intercept at -2 and 0 at 2. So as you can see, just by looking at it, I can connect the points like this. It's going to be something like this. Now, what about on this side? Well, how do you know? Well, you have to make a number chart. So the number chart involves all the denominator, the x values, which is at -2. So let's take a look at any number before -2, for example, -3. So I'm going to plug in -3 into my equation and tell me what sign you get. So -3 minus 2 is going to be negative, and then -3 plus 2 is going to give me negative. Negative, negative becomes positive. Now let's plug in a number that is greater than -2. For example, 0. So then I'm going to plug in 0 into the equation. 0 minus 2 is negative, and 0 plus 2 is positive. So negative divided by positive is going to give me negative. So it makes sense. So anything after -2 is going to be below the x-axis, okay? But anything before the -2 is going to be above the asymptote, okay? So in this case, before I set the zero x-axis because we were assuming the horizontal asymptote was at 0. But because my horizontal asymptote is now y equals 2, if it's positive, it means it's going to be above the asymptote. So it's going to be this way, okay? And following the asymptote. Okay, let's try one more. So then now this is case number 2. So the only thing that's different with case number 2 is that the denominator is a factor of ax plus b. So what does that mean? Everything is same except that there is going to be a hole at x is equal to negative d over c. Why? Because it cancels out, so I'm going to isolate for cx plus d equals 0. You isolate for cx equals negative d, x is equal to negative d over c. Because it cancels out, there is a hole. Okay, and then you'll notice that for x-intercept, there is none because it cancels out. So that's why you get a constant in the numerator. Okay, so let's try this one. It says find the characteristics of y is equal to 3x plus 6 over 2x plus 4. So I'm going to rewrite it. It's going to be, so I'm going to factor numerator and denominator with a common factor, x plus 2, and then common factor of 2, x plus 2. Okay, now you will notice that x plus 2, it cancels out. So my simplified version, it's going to be 3 over 2. That's my equation. So as you can see, there is a hole at x equals negative 2. So we know that for the domain, x cannot be negative 2. So to find the hole exactly, I'm going to plug in negative 2 into the equation, but it's 3 over 2. So it's just going to be 3 over 2, the same. Okay. What about the y-intercept? So we can find the y-intercept when x is 0, but there's no x. So y-intercept is at 3 over 2. Okay. What about the horizontal asymptote? So for horizontal asymptote, the degree is the same, so you look at the coefficient, which is 3/2. Now, do I have a vertical asymptote? In this case, there are none, because in the simplified equation, the denominator is just a constant. Okay? So if I have to draw this, let's label all the important numbers. So it looks like I have a y-intercept at 3/2. Okay, and x, there's a hole at -2. So if I have to draw in a different color, it looks like we have a straight line, a horizontal line at y is equal to 3/2. But keep in mind there is a hole at 2, and it's going to go forever like this. Okay, so that is my final graph of the given function. So at first, it may look really complicated, but you can simplify further by factoring and canceling it out. Now next, so find the function in this form. Okay, so this is the opposite. So we're given a different characteristics, horizontal asymptote at y is equal to 2. So let's rewrite this. Y is equal to 2. I have a vertical asymptote at x is equal to 1, and it looks like x-intercept at -1. So we know if it has a horizontal asymptote, that means that the degree must be the same. So f at x, the degree is same, and it's going to be 2/1. So 2/1, okay? And we have a vertical asymptote at x equals 1, so it must be x minus 1, right? So that when you take it out of the bracket, when you make it equal, x is equal to 1. So you think opposite. And then we have a y-intercept at -1. So y-intercept happens when you let y is equal to 0, meaning you look at the numerator. So what does that mean? You want to make the numerator equal to 0. So it's going to be 2x plus like a number. But we know that it's going to be, so let's say a number. So we know it's going to be 0 is equal to 2x plus a number. Well, we know that the x-intercept is going to be -1, meaning that it's going to give you 2. Why? Because we can assume that we can factor out the 2 over here. So it's going to be 2x plus 1, x minus 1. Just by looking at it, we know that the x-intercept is going to be -1. And if I want to put it together, it could also look like 2x plus 2 over x minus 1, like this. Okay? But I thought this might be easier to figure it out because we know that the numerator, it has to give me -1 when it equals to 0. So therefore, my equation will look like this. Okay? So if I have to draw it, roughly, it's going to be y-intercept -1, it's -2, and then we have a asymptote at 1. So, and then we also have asymptote at 2. So it's going to look something like this and this. Okay, good. Next, so graph the function. So it looks a little bit complicated now, but that's okay. We want to factor if we can as much as possible. So for numerator, I'm going to do a trinomial using decomposition. So if I were to factor, it's going to be 2x plus 3, x plus 2. And then for denominator, if I were to factor, it's going to be x plus 2 and x minus 1. So as you can see, you have the same thing. It cancels out x plus 2 and x plus 2. So my simplified version is going to be 2x plus 3 over x minus 1. And we know that for domain, x cannot be -2 and 1. So it looks like there is a hole because it cancels out at -2. So I'm going to plug in -2 into my simplified equation. I'm going to get 1/3. Okay. Anything else? Let's see. We do have a vertical asymptote at x is equal to 1, horizontal asymptote. So because the degree is the same, so you look at the coefficient of the same degree, which is 2 over 1. So which is 2. And the y-intercept, I'm going to plug in x as 0 into my simplified equation. So it's going to get -3. And what about the zeros? So for 0, I'm going to make the numerator equal to 0, right? So y is equal to 0. So 0 is equal to 2x plus 3. X is equal to -3 over 2. Okay. This is x, y. I'm going to label all the important points. So there's -2, 1/3. And this is 2. And we have a x0, -3 over 2. And we have a y-intercept at -3. And there is a asymptote at 1. Okay, so I just marked all the important points. So let's see. So we have a vertical asymptote at 1. So at 1, I'm going to draw a dashed line. And we have a horizontal asymptote at 2. Again, another dashed line. Y is equal to 2. And we have a y-intercept at -3. We have a 0 at -3 here. And a hole at -2, 1/3. Here's a hole. Okay, so now we have everything, but we need to figure out how we're going to draw the graphs. So just by looking at it, we know that I'm just going to connect the dots. So it looks like this, connecting, connecting, and going this way. Okay, then it looks like from this side, it will be this way. Well, how do I know? Well, we can do the number chart again. So the number chart, you do it including all the zeros before you canceled everything. So -2 and 1. So let's plug in a number that is smaller than -2, like for example, -3 into my simplified equation. So if that's the case, then it's going to give negative, it's going to be negative. And let's plug in a number that's in between -2 and 1, which is 0. So 0 is positive over negative, it's going to be negative. And let's plug in a number that's greater than 1. So it's going to be positive divided by a positive number, positive. Okay, so as you can see, anything before 1, it's going to be negative, meaning below the horizontal asymptote. Okay, so there you have it. And then anything after 1, it's positive, meaning above the horizontal asymptote. And there you have it, like this. Okay, so please double check using a number chart. Graph the function. Okay, so more practice. So first thing again, let's see if I could factor. So f at x is equal to, so I have a common factor, which is x. X minus 2, and x plus 1. So unfortunately, nothing cancels out. So we know that x cannot be equal to -1. So we have a vertical asymptote that x is equal to -1. Now what about the horizontal asymptote? It looks like my numerator is bigger than the denominator. So that means there's no horizontal asymptote. There is an oblique asymptote because it's greater by 1 degree. So to find the oblique asymptote, you're going to do a synthetic or long division. So let me do a synthetic. So always decreasing order. So 1, -2, and the constant is 0. And my divisor is going to be -1. So it's 1, -1. You add them, -3. You add, you multiply, 3. You add, it's 3. So we don't care about the remainder. So it looks like my oblique asymptote is y is equal to 1x minus 3. Okay. Now what about the zeros? So for zeros, you let the numerator equal to 0. So 0 is equal to x minus 2. So we have x is equal to 0 and x is equal to 2. Now what about y-intercept? Y-intercept happens when x is equal to 0. So I'm going to plug in x 0. It's going to be 0. Okay, so therefore we have all the characteristics. This is x, y. Let me label all the important points. So it's like -1. So we have 0, and then we have 2, and we also have -3, so the line. Okay, let me label all the key characteristics here. So vertical asymptote at -1. Okay. And we have a oblique asymptote. And okay, so let me circle the 0. So 0, 0, and 2. And we have oblique asymptote at x equals, y is equal to x minus 3. So we have a y-intercept at -3. And it's going to go something like, so it's 1, 2, so it's 0. It's at 3. So it looks like I have a vertical, or this is the oblique asymptote at y is equal to x minus 3. So if I have to draw this, the graph over here, it's going to be in between, because the points are right in between the vertical and a oblique asymptote. It's going to look something like this. Touching and touching like this. Okay, approaching. And then over here, it's going to be going this way, like this. So not touching the oblique or a vertical asymptote.